No B. How many for C? Anybody for C? How many for D unrelated? Answer is C. And your girls a whole of the are they mirror images to each other? Yes. But are they identical or non-identical mirror images? Those are identical mirror images. Now, for example, look at this molecule here. Is there anything that kind of stands out at you? Take my little cartoon drawing. Head and feet. Look at your head and feet for that molecule. Anything stands out at you? It's a molecule. Head and feet be the same. Notice in a regular enantiomer molecule, the head and feet are going to be different. If you go into a molecule and they give you like a mirror image of the molecule, check for the head and feet. If the head and feet are going to be identical, it will be a Meso molecule. Again, check for head and feet. Okay, the first thing you probably want to look, you got fixated about the fact it's a mirror image. Remember we gave the definition for the stereoisomers. We gave the definition for an enantiomer, which is a stereoisomer, non-superposable and non-identical mirror images. We gave it a diasteromer with the stereoisomer, non-superposable, non-mirror images. And then we had the definition for Meso, which is a stereoisomer that has an identical mirror image. There's two mirror images in one. That is will be with the Meso, there will be an enantiomer and also with the Meso. Both will have mirror images. The difference between the Meso versus the enantiomer, the Meso will have the head and feet being the same. So again, when you look at a molecule, when you start seeing the mirror image is cool, but also make sure that the molecule, the head and feet of the molecule are not the same. Anytime the head and feet of the molecule are the same, it will be a Meso. The reason why it will be a Meso, because inside the molecule there's an internal plane of symmetry. If you were to draw a line through this carbon, through this molecule, through the middle, you can actually fold this molecule over and make the top part of the molecule equal to the bottom part of the molecule. Again, for Meso molecules, they have what is called an internal plane of symmetry, which inside the molecule is a plane of symmetry. Here's also another internal plane of symmetry. Remember back in G-Chem, you were talking about far as polar bonds and non-polar bonds, in which you can have a molecule that has polar bonds, but the molecule itself is considered to be non-polar. For example, in CO2, the bond between carbon and oxygen would be polar, but the molecule CO2 itself is considered to be non-polar. That is because it can pull in one direction, one particular amount, and can pull in the other direction, one particular amount. The net amount will be zero. Similar to a Meso. In a Meso, you may have like a chiral-carbon atom in the molecule, but the molecule itself will be considered to be achiral or non-chiral. What's that funny? I also want to give a look at some other relationships. Let's see, we're giving them 3R, 4S, and a couple of neighbors, but 3 bromo, 4 chloro, no name. And you have 3S, 4S, 3 bromo, 4 chloro, no name. What is the relationship between those two molecules? And do we need to draw the molecules in order to determine the relationship between the two molecules? What is the relationship? Would the relationship be enantiomers, diastereomers, meso, or unrelated? And can we do the drawing without doing, can we actually determine this, the relationship without doing the actual drawings?
Let's do the drawings.
You have to do the drawings. Without doing the drawings, what do you need to focus on?
3R and 3S.
The little R, the 3R and the 4S, and the 3S and the 4S. So we take this, we've got 3R, 4S, compared to 3S, 4S. Are they enantiomers to each other? If there will be an enantiomer, what's the enantiomers to? What is the enantiomer to 3R, 4S? Remember, before I say enantiomer would be the mirror image. So whatever the R value or RS value would be, then the mirror image would be the exact opposite. So if this here was 3R, the mirror would be 3S. This here being 4S, the mirror would be 4R. So we see they're not enantiomers to each other. Are they diastereomers to each other? What happens in diastereomers? One of the group will be a mirror, and the other one will be the same. Notice right here we mirrored carbon number 3. That was the mirror went from R to S. What happened to carbon number 4? Stayed the same. The relationship between those two molecules will be diastereomers. The relationship between the two molecules, between these two, they are diastereomers. Now, a little drawing one, I'm not going to give you one, it's for a drawing one in which you have the little top part of the molecule and the bottom part of the molecule being identical. If you're going to get a molecule probably involving meso, you have one probably with the structure already drawn out for you. So I'm going to try to trick you because of the fact that we don't have it drawn out. I'm going to ask a question on an exam. We got BR, CL, F, H. What is the RS configuration of the enantiomer of the molecule to the left? Now could I ask one exam numero tres? What is the RS configuration of the enantiomer of the molecule shown? Molecule to the left. How would we end up answering this question? What we're going to do? Do we need to draw the mirror image of the molecule that I drew on the board? Do we need to draw the mirror image of the molecule? All we have to do is what? Determine the configuration of the molecule shown. The enantiomer will be the opposite letter. Now in this molecule here we have a solid wedge and a dotted line. The solid wedge indicates what? Forward. Dotted line indicates back. First we're going to do is go ahead and identify groups. We got bromine is 1, chlorine is 2, fluorine is 3, hydrogen is 4. We're going to do our curved line connecting 1 to 2 to 3 with direction. We go clockwise. Clockwise gives us a relative configuration of R. Who gets the final say so? Group 4. It's group 4 forward or backwards. So the configuration is going to be S. What's the answer to this question? What's the answer? The answer will be R. The molecule is going to be S. I didn't ask for the molecule, I want the enantiomer of the molecule. If the molecule is S, the enantiomer would be R. Get all quiet here, like, what is he talking about? And the enantiomer would be the mirror, whatever the value was for the molecule itself, the enantiomer would be the exact opposite letter. So you do a uniform, and the answer we put the molecule would be in S, but the answer to this question will be R. So the answer of S will be R. And that will be the answer for that particular question. And all I needed was just one letter. And just by going in the bar, without even trying to do the question, you got a 50-50 chance of getting it right anyway. And with 2 letters, R or S. Then again, we can have the molecule with the little wedge lines and dotted lines. And you'll probably also say, can we do little molecules like that Newman projection? Can we actually determine if a Newman projection molecule is chiral or not? And to Tanya, I wasn't even thinking about doing that one. She was asking about here, can we do a molecule that way? Yes, we can. Here we have a new projection of a molecule. In this molecule, how many carbon atoms do we have? In this molecule? How many carbon atoms?
1.
1, 2, 3, 4, 5. 1, 3. Everybody see that CH3 group, right? 1 carbon atom. What's this point understood to be?
Carbon.
Carbon. What's the big circle understood to be? Carbon. So there's 3 carbons. Next we're going to identify about 3 carbon atoms. Is any one of our 3 carbon atoms chiral? How are we going to determine if any one of our 3 carbon atoms is chiral? We're going to eliminate out what type of carbon atoms? CH3 and CH2s. Do we have a CH3 or CH2 carbon atom present? Then we'll see this molecule has 1 present. Do we have any more CH2 or CH3 carbon atoms? Yes or no? 50-50? Someone's like doing hand signal, but is it yes or no? Remember, the second carbon atom was in the back, has 3 hydrogen atoms directly attached to it. That carbon atom is not chiral. So the carbon atom that's chiral is going to be the carbon atom in the front, carbon number 1. What atoms are directly attached to carbon number 1?
OH and H's.
We got carbon. Uh-oh, we got a wrong molecule here. Change that one up. The molecule will be carbon. That'll be CH2OH. Otherwise, I would have two of the same groups in the same carbon atom. So I do still get rid of this carbon atom here. Now, what's attached to our carbon, the first carbon atom? We got a carbon, we got an oxygen, we have a sulfur, and we have a carbon. We're going to arrange our groups according to atomic number. Which atom has the highest atomic number? Sulfur. And where we get our atomic number values from? The periodic table. So you got to memorize those. We got 1, 2, 3, 3. So we have a tie in carbon atoms. We have to go back and do a tiebreaker. What atom is directly attached to the top carbon atom? What atom is directly attached to the top carbon atom?
I have a question.
Yes.
Where is this other carbon coming from? If we mark out the one at the top.
Remember, in the new projection with the dot, understood to be a carbon atom. The circle is also understood to be a carbon atom. Right? In the new projection, you get a dot and a circle. Those represents carbon 1 and carbon 2. We also had another carbon actually shown, and that's carbon 3. So there's a total of 3 carbon atoms. Of the 3 carbon atoms, we go through the process to eliminate or try to identify which carbon atom is actually chiral. We get rid of the CH2 carbon atom. It has 2 or more CH2 and C3. Get rid of the CH2 carbon atom. We also have another C3 carbon atom, which is the carbon atom number 2. Attached to carbon number 2 is 3 hydrogens. What's the little 3 hydrogens attached to carbon number 2? H, H, and H. When we get rid of CH2, the C3 groups. Following now, or still not seeing it? Okay. Now we look at this, we got this point, which is the point is this little carbon atom in the carbon number 1. Attached to carbon number 1, we have a carbon. Also attached to carbon number 1, we have an oxygen. Attached to carbon number 1, we have a sulfur. And finally, attached to carbon number 1, it's a big carbon in the back, which is carbon number 2. So there's 4 atoms directly attached to the carbon number 1. Yes?
So, even though you cross out the C for CH2, it's still not counting because you just did it.
No, I just eliminated carbon atom as being chiral. It's still there.
That's what I'm saying, so you still count it.
Yes.
It's gonna be like slightly.
I just put a slight, that's why I said to get rid of it, because I want to make sure we're not erasing it out. We're just taking it out of the running as being chiral. Just it's no longer considered being a chiral carbon atom, but it's still a carbon atom that's still present. So now we have a tie between the carbon atoms. We're going to go to our tiebreaker and figure out what atoms directly attached to carbon. Attached to carbon number 1, we have an H, H, and an O. Attached to carbon number, attached to the back carbon atom is 3 hydrogens. H, H, and H. What do you do next as far as the atoms? Cross out all the atoms at the same. For every 1 hydrogen atom, we cross out 1 hydrogen. H, 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 H. Now we have an atom that's different. So we have oxygen versus hydrogen. Atom with the highest atomic number. Oxygen, making this group number 3, and the other group becomes group number 4. We're going to put some color markers so we put our numbers. Start at the top, we got 3. The next group is going to be 2. The next one is 1. And finally, we got group number 4. What we're going to do next? connect 1 to 2 to 3. When I connect 1 to 2 to 3, what direction am I going in? Clockwise or counterclockwise? Counterclockwise will be what letter? S. Who gets the final say so? Group 4. Is group 4 forward or backwards? Remember, carbon number 2 is understood to be back. In this particular drawing, there's only 2 groups that's actually set as far as being forward or backwards. Carbon number 1 is defined as being forward. Carbon number 2 is understood to be back. So we got group number 4 being back. And when we say as far like little groups, does it stay if it's back or does it be opposite if it's back? Stay as being back. So the configuration for this group would be, this molecule would be S. Isn't that fun? Yes.
Group 3.
Mm-hmm.
You get the HHO from H, those two as well.
Which one's to my district?
Number 3.
You got number 3, yeah.
Okay, so where did you get? You got your HHO from?
From attached to carbon number 3 is 2 hydrogen atoms and an oxygen. If you draw the bonds out, C, H, H, O, H. So attached to the carbon atom will be an H, an H, and an O. Now for the second molecule, to try to determine the second molecule, would that second molecule be chiral? Or if it is chiral, what is the RS configuration for this molecule? First we're going to do is we're going to relax. We have how many carbon atoms in the molecule? Yes. Yes. You do let me put a molecule A and molecule B. You talk about molecule A or molecule B? Molecule A is what I'm trying to put a letter because we have kind of going to the new one. Next molecule A, yes. Say it again, I couldn't hear you. Oh, but you can mention, I just I couldn't hear it because it's still kind of distance between us. Oh. I'm going to come close to you and if I can see it for you. Okay, maybe something be about coming up. I'm going to draw it out for you. Okay. First, we're talking about, can I actually go through the process and have more than one individual group of stuff attached to it? And yes, you can actually have, because if I have 3 carbon atoms, you can actually have more than 3 carbon atoms. In fact, we're going to do one in which we're going to have more, basically we have like a carbon molecule. Actually, we're going to end up being distinct between molecule, which you have the difference as far as isotopes, as far as like you have a hydrogen 1 or hydrogen 2, hydrogen 3, or for example, look at carbon 12, carbon 13, carbon 14. And now for this molecule, it's understood to have 2 carbons. We have a CH3 and a carbon with 4 hydrogens. Those are 2 carbons out of the total. The first, which is number 1, has 3 hydrogen atoms attached to it. Because we can eliminate all CH2 and CH3 groups, we can get rid of the first carbon atom. First one is taken out to run it as being carbon. Next, what we're going to do is look at carbon number 2. Carbon number 2, it has to be chiral, or the molecule got to be chiral the whole beginning with. We're going to get rid of carbon number 1. If we get rid of carbon number 2, the molecule is not even chiral. We'll look at carbon number 2. Carbon number 2 does not have a CH2 or CH3 group. Let's check as far as that one. Carbon number 2 does not have a double bond, so it's good at that particular value. If I look at carbon number 2, does have 2 of the same groups. Same group. Bromine and fluoride, let's say you have like a little twins, or just like this, we got 2 guys, the same thing. One tall guy, one guy, short guy, not basically the same guys. Now the guys are twins, we can say that they're the same. So we got different atoms. So now we're looking at what is attached to carbon number 2. Attached to carbon number 2, we have a bromine, an iodine, a fluorine, and we have a carbon. What we're going to do next is what? Assign according to atomic number. 1 is going to be iodine, 2 is going to be bromine, 3 is fluorine, and 4 is carbon. As a group, we're going to put in our numbers. We have 2. We have 1. We have 3. And group number 4 would be the carbon in the firm. Next, we do a curved line connected 1 to 2 to 3. Curved line connected 1 to 2 to 3. What direction are you going in? Clockwise or counterclockwise? Counterclockwise, which will make it S. Who gets the final say so? 4. Let's go forward or backwards? Forward. It'll make configuration R. Yes.
What was the rule about the groups being the same that are attached to the carbon? I just forgot it.
Now, if the groups are the same, if 2 of the same groups, the molecule can't be chiral. In order to be a chiral carbon atom, the carbon must have 4 different groups. Not necessarily 4 different atoms, but 4 different groups.
Right. So, I look at BR and I and F, and they're all, aren't they all highlights?
Yeah, the highlights, but they're not the same group. I mean, like, you can have carbon, sulfur, what's the other element that's not forming there? Those are the same group, but not the same elements. They got different numbers. Bromine and fluorine are not the same elements, huh? They're the same groups, yes, but they're not the same.
Like, have to be the same, identical,
It'd be to be the same. I have a bromine. This got to be bromine, and another atom got to be bromine. And those would be the same. It's not like it's not because they're the same group. Because you're the same group, all y'all, every atom in the same group is not the same. They have similar properties, but not the same. Fluorine is not the same as chlorine. Yes.
For this one, why didn't we change that one to R?
Remember for this first, for A, right?
Yeah.
A, where's group number 4? Forward or backwards?
All of was forward compared to that.
Well,
Are we talking about the circle on the outside? Or
In this molecule, the carbon atom is in the dot or is it the circle?
I don't know. It must be the circle because the dot is just like this.
Come on, so you keep mixing these two together. For this one right here, you ask them why you make this video, keep that the same. In this one right here, is the first group, is the carbon atom, the first carbon atom or the second carbon atom?
It was the first one.
The carbon atom is one in the first.
Right.
First one. So carbon number 4 is carbon number 4 in the front or in the back?
Front.
This is yourself.
Right.
Carbon, the 1, 2, 3, 4 was attached to the carbon atom right here.
So back.
What's attached to the carbon atom going to be a carbon, an oxygen, a sulfur, and carbon number 4.
Okay.
Carbon number 4, which is the circle, is in the back. Carbon number 4 is in the back. I'm going to do the same thing when I
I
ask.
see what you're saying. Is that what it is? For this one,
Let me get the one out, Jasmine. Let me get the question here first, and we get here. Yeah, I do acknowledge you have to hit your hand out. I want to try to get them, then I get you.
No. So.
I get you. Tess, you were asking about the group.
The same thing that she was asking about.
Now, the second molecule, we have 2 carbon atoms. The first carbon atom has attached to a what? 3 H's. You got CH2 and C3s are not carbon atoms. So we get rid of that carbon atom being carbon. We look now at the back carbon atom, which is the big circle. What's attached to the big circle carbon atom? We got a Br, an F, and an I. Are those two the same? Are those, and also carbon, are any of those groups the same? No. So you have 4 different groups. The carbon atom for molecule B is carbon number 2. Carbon number 2, the new projection understood to be at the back. Carbon number 1 is always understood to be in the front. So for molecule B, is the carbon atom in the front or in the back? We said the carbon number 1, which is the dot, has what attached to it? 3 hydrogens. You can't have the carbon can be carbon, you have 3 of the same groups. So the carbon atom is actually carbon number 2. Now what's attached to carbon number 2? A fluorine, a bromine, and an iodine. And the 4th group is going to be carbon number 4. I mean the carbon atom in the front, which is carbon number 4. Group number 4. We're going to then assign the group bromine, iodine, fluorine. And the last group will be carbon. So we got bromine, going clockwise, iodine, fluorine. Then I put my last group, which is carbon number 4. I'm assigning by atomic number. Bromine is 2, iodine is 1, fluorine is 3. So I put my numbers 2, 1, 3, and I put a little small one in this near carbon number 4, which is at the little dot. That's carbon number 4. I would then connect 1 to 2 to 3. We go in what direction? Counterclockwise, which would be S. Now, in order to figure out what my absolute configuration, I need to know what group number 4 is. The group number 4, forward or backwards. Which carbon is group number 4? The dot or the circle? The dot. The dot is understood to be forward or backwards? Forward. So group number 4, which is the dot, is understood to be forward. If group number 4 is forward, the configuration will be opposite. So initially I said it was S. The opposite of S will be R. So that's why this molecule, not this carbon atom, is one here. The carbon one is actually be the big circle. The big circle is the carbon atom. I can get Jasmine. Jasmine.
Okay, yeah, here's my question. So because we're doing carbon 2, the R is referred to
Oh, that's why, yeah, I meant, it should have been a circle, the big circle, the one that's carbon. The circle's the one that's carbon.